So this is an interesting problem from a previous year, right, in CBSE. So here what are they saying is that they're not asking you to calculate anything. They're asking you to prove something over here. So what is the problem say? If the sum of first n terms of an AP, okay, is same as the sum of first n terms where n is not equal to n. Okay, suppose you have, if you have a series of n terms, m as in mother, okay, a series in AP series of m terms, and you have a AP series of n terms, right? So what is the sum of m terms? You are going to get m is equal to m by 2 times 2a, right, plus m minus 1 times d. This is the sum of first n terms of a series, right? Similarly, Sn, n terms ka series, we know the formula, it's the same stuff, a plus, sorry, 2a plus n minus 1 times d, right? We assume that a and d are same. The first term in this particular series and the first term in this particular series same, and the difference is also same, but the series is different. The number of term n can take any value. M can take 100, n can take only 50, because they are saying that n is not equal to n. Now what are they saying? If the sum of first n terms of an AP is same as the sum of first n terms, therefore what they are alluding is that Sm is equal to Sn, right? Okay, so now look at it. Let's equate these two. What do you get? M by 2, 2a plus m minus 1 times d, right, is equal to n by 2 times 2a plus n minus 1 times d, right? Okay, so now what are they saying? Then show that the sum of first m plus n terms. What will be the sum of m plus n terms? I can put it like this, is equal to m plus n by 2. In the place of n, I'm going to put n plus 1. This will remain as 2a plus inside, instead of m, we can put it as m plus n minus 1 times d. This is the sum. They are saying that this will be equal to 0. Okay, this should be equal to 0. So now what we need to do is that we need to solve this one and arrive at this. Okay, look at it. So what do we do? I'm going to basically open up. This becomes am, right? This becomes am. Okay, let's leave it as 2am by 2 for easy calculation purposes. Then I'm going to open up this one. This will become md by 2 times m minus 1. Okay, I have opened up. Similarly here also I'm going to make it as 2an by 2 plus it becomes nd by 2 times n minus 1. Okay, I can open it like this. Now what I'm going to do is that bring these to this side. So 2am by 2 minus 2an by 2. I bring this on this side. Okay, and here this will become n square d by 2 minus nd by 2. And when you get this one this side, it will become minus n square d by 2, right, plus this is a minus over here. When it comes this side, it will become plus, it will become nd by 2 is equal to 0. I don't have anything on the right side, right, equal to 0, because I've brought everything over this side. Now look at it, how I'm going to play around with this one. So you need to understand the question well, so that you'll be able to do everything. Okay, so let's rub this. We'll leave this one because that is what we are going to use later. Okay, so what do you have here? It is 2am. So what I'm going to do is that, can I do this here? I can write this one as implies, here what is common, if you look at it here, 2a by 2 is common, right? So I'm going to put it as m, so I'm going to put it as m minus n times 2a by 2. Okay, I'll leave it as like this. It was sum of first m plus n terms. Okay, so here what do I get? I'll take these two terms common over here. So I get md square and nd square. So I can take d by 2 common. This becomes m square minus n square. Right? I get a m square minus n square. Now I will take these two common. Right? What do I get? I get a minus d by 2 m minus n. M minus n equal to 0. Look at it. Okay. So what did I do? Between these two, I took out 2a by 2 common. You're left with m minus n. Between these two, I took d by 2 common, m square minus n square. And between these two, this one and this one now, I took a d by 2 common, I have m minus 1. Now if you look throughout, right, you have a m minus 1 common. You can remove that because m minus 1, here you will be left with m plus 1 because m square minus n square is nothing but m plus n into m minus 1. That m minus n gets cancelled out, here m minus. So what are you left with? You are left with 2a by 2 plus d by 2 times you're left with m plus n minus 1. Look at it. Okay, so this is what you have left with. Now can I take where did this m minus, did we miss out something? Is equal to 0. Okay, so we get that. Now okay, fine. So now if you look at it, right, okay, we are good. So I was just worrying that I have missed out something. So now what I'm going to do is that I'm going to put this in the particular format. I'll take half out and I'll write it as like this. Is equal to 0. Look at it. What do you get? Half times 2a plus m minus 1 times d is equal to 0. When I go ahead and put over here, I can write this one also in the similar fashion. M plus 1 times half times 2a plus m plus 1 minus times d is. So look at it. This entire quantity is 0. When you go and put n plus n times 0, you get a 0. So you have proved that sum of first m plus n terms will be equal to 0. So this is how you will solve it. So you need to be a little bit tricky to basically identify the problem and see that how can you approach and put the values and get the answer, prove it. Okay, nice problem, very good problem. These are the kind of problems you're going to get in boards. Remember all this. Okay, great.